Hey everybody, thanks for coming. Welcome to Continuous Delivery NYC. This is going to be our last meetup of this year, and we have not yet released anything for 2020. But the thing that I say before every meetup is that Continuous Delivery NYC is one of these groups that gets the biggest value from the community by reaching out to the community for talks. So if you have a story that you'd like to share at this meetup, let me know, and we can work together to come up with a good time to bring that in. And just to say a few words about myself, my name is Daniel Rolnick. I'm the CTO here at ShopKeep. ShopKeep it is a tablet-to-cloud point of sale, which is less interesting to you. But the interesting bit is about ShopKeep's commitment to its community. And by its community, I mean you and every one of you. Like, each of us learn every day, whether it's from our peers, whether it's from conferences we attend, meetups we attend, Stack Overflow, things like that. So please, if you can, give back to the community, whether it's through meetups, as our speaker is doing tonight, or through any other medium. So please, we all will grow as a global engineering community by working together. So with that, I'd like to welcome you to tonight's talk, which is going to be about GitHub Actions. Sean Sullivan is going to be speaking. He's currently an engineer, principal engineer at Twilio. He's formerly from the Saks Fifth Avenue company as well. And we're looking forward to hearing his talk.
All right, it's good to be here. So I'm Sean Sullivan, and I'm here to talk about GitHub Actions. Part of this talk tonight is based on a presentation I gave 2 months ago in Portland. I live in Portland, Oregon. I work for Twilio. I'm part of the platform engineering team at Twilio. And what that means is that we have a group of engineers who focus on doing heavy lifting, providing common platform infrastructure that all the product teams can build on top of. So we see ourselves as a team that creates building blocks, and then hopefully that makes the product teams more productive. So fair warning, when I was creating the slides tonight, I was listening to a lot of Run DMC, so you may encounter a few slides with that theme. So my background, I'm actually from New York. Born in Yonkers, raised in Albany, and as a native New Yorker, listened to a lot of hip hop on boomboxes in the '80s. Nice, a few more out there. Run DMC is pretty much my favorite hip hop act of all time. So this presentation is somewhat of a tribute to Run DMC. So when I was, learning to code, I actually went to school upstate at RPI, and kind of like in the early days, learned how to write code in C, C++ at RPI, and then later moved to the West Coast. I joined Intel, worked on like a microprocessor project briefly, and then moved over to do like more customer-facing SDKs and developer tools like that. More recently, I was working for Gilt. Gilt used to have their main office right here on Park Avenue, like 2 or 3 blocks north. There's a few Gilters in the room here. So one of the things I liked about working at Gilt was we actually had a really good solution for deployment automation. We called it Ion Cannon, and it was built by a few experts in the company who really knew how to make bulletproof deployments. And so having build automation and deployment automation working well in your company, it frees up your engineers to really focus on other value-added work that they need to get done. And I think Gilt was really successful at doing that. After Gilt, I ended up working on projects for the Hudson Bay Company, and Hudson Bay owns Saks Fifth Avenue. And one of the highlights working there, I got to work a lot with AWS Lambda, and really I focused a lot of my time on how to make our Lambda deployments reliable and automatable. So we had a pretty good build and deployment system for Lambda functions, which I think worked really well. More recently, I'm at Twilio. The team that I'm specifically working on builds the deployment pipeline tools at Twilio. And we aspire to provide tools that make all the product engineers productive, so they don't have to worry about all the nitty-gritty details of promoting code through a pipeline system and getting to production. We provide a user interface. We provide streamlined templates and hopefully tools that people want to use. All right, so trivia question. Who knows what DMC means in Run DMC? It actually means devastating mic control. But the way I like to think about it is it's about deploying microservices continuously. And this has been a common theme at like my current job and my previous two jobs. All three companies, Gilt and Saks Fifth Avenue and Twilio, all have microservice architectures. That means that there's a lot of opportunity to deploy things. And we try to streamline it so that we can do continuous releases. Try to make it as easy as possible for developers to release. Try to remove as much friction and as many barriers as possible. And so this is how I got interested in GitHub Actions. GitHub Actions is relatively new. I think it was about a year ago, GitHub announced the Actions technology itself. They kind of released it as like a preview or a beta. But Actions has come a long way. So the idea behind Actions is that every developer has some sort of workflow that they go through. You're editing your code, you're pushing code, you're creating pull requests, you're closing pull requests. You want to build and compile your code. You want to run a test suite, and then you might want to package your code. You might want to release an artifact, and then hopefully at some point you release it upon your users. And GitHub Actions is a technology that facilitates the automation of any of those steps. And it's not just automating the steps, it's also like aligning a sequence of steps into like sort of a miniature pipeline. So if you know that you want to do, you want to run some unit test suite, and maybe you want to run some integration tests, and then maybe you're ready to package your code into a Docker image, and then you want to publish that image, and then after that you might want to deploy it into some staging server or production environment. Actions can be used to orchestrate all of those steps together, and GitHub calls that a action workflow. So if you think about it, it's very similar to other CI tools that are out there. I'm sure people have used like Travis CI or Circle CI, Concourse, Bitrise. AWS has code build, code pipeline, code deploy. There's a lot of solutions out in the space. But it seems to me that, that CI/CD has become more of a commodity. There's many solutions that are all fairly similar. And so GitHub, kind of entered this space recognizing that CI/CD is generally a commodity for most users. And they wanted to provide an integrated solution that's just pre-built, pre-integrated into GitHub. The Actions platform itself, it is available on github.com. You can also access it with a pro account, or if you have the Enterprise Cloud Edition, you can also use Actions. The one thing where Actions has not yet been released is if you're running GitHub Enterprise, but you're running a copy that's on premise on your own hardware or your own like data center, the GitHub Enterprise on premise has not yet supported GitHub Actions. So keep that in mind. But the way I like to think of it is this. Traditionally, people that wanted to integrate with the GitHub platform had to use the GitHub API, and then you had to register callbacks. And so these were like, you'd build like some webhook, you'd configure the webhook, and then when the GitHub platform had an event that it wanted to tell you about, it would send you an HTTP post to your callback URL. And that works. Like, people have been using that for a long time. But GitHub Actions kind of is the next generation beyond that webhook callback mechanism. If you're using GitHub Actions, you don't need to build a webhook, because all of your GitHub Actions lives in GitHub. So it doesn't need to like call an external HTTP server to notify you of an event. And I like to think of this as like a serverless version of like the webhooks that people used to build. You don't really need to like provision a server. You don't need to set up an HTTP endpoint. Actions will just do things for you. So workflows are very similar to like a Travis CI workflow or a Circle CI workflow. You set up steps that you want to execute, and then those steps get executed on GitHub managed servers. They don't run on your environment. These workflows are running on your behalf in GitHub's data centers. And like every CI/CD solution in the world, it all comes down to YAML. I was telling a friend in Portland recently that I'm a YAML engineer, and he thought I was joking, but I wasn't. I probably edit YAML files every day. So the key takeaway from this slide is that when you're setting up a GitHub workflow, you need to create a subdirectory in your repo, and it's called .github/workflows. And that is a directory, and that directory can contain one or more YAML files. So if you just want one workflow, just put one YAML file in there. If you want 10 workflows, that's going to be 10 files. And I actually see this as an opportunity for people to migrate away from Travis. I mean, if Travis is working for you, I mean, you could keep using it. But if you're setting up a new project, you might look at GitHub workflows for new things that you're building in the future. I'll show you an example in a few minutes of a project where I wanted to migrate from Travis to GitHub Actions. It wasn't that hard, but it really comes down to how complicated is your workflow that you set up in Travis or Circle. If you have a big complicated workflow, it might be hard to move over. It won't be like a straightforward thing. You'll just have to figure it out. But if you have a really simple YAML file in Travis and it's only like 5 lines of code, you can pretty much do that in 5 minutes. So like I said, GitHub Actions is based on it's a way to react to events that are occurring within the GitHub platform. So if someone opens a pull request, that generates an event. And you can write some YAML that declares that you're interested in knowing about that event when it occurs. You can also get notification about push operations in your repo. If someone was like pushing a new commit to master or someone pushes a new tag, you might want to know about that. You can also use this there's this other event called schedule. And this is kind of useful if you want to set up like a recurring scheduled job in GitHub Actions. Think of it as cron scheduling in YAML, the modern version of cron, cron.yaml. But the basic idea is that you have events. You set up a workflow that's going to react to an event. And then inside your workflow, you will have multiple steps. And each step in your workflow is just executing an action. And an action is like some code that either you can write your own custom action, or you can just reuse actions that are already provided to you. And I believe Circle CI has like a similar mechanism. Someone told me they had a thing called orbs. Anyone using Circle CI orbs? It's basically a way to like extend Circle CI beyond its like base capabilities. And anyway, GitHub Actions is basically the same idea. You can reuse actions that are provided by third parties. You can use actions provided by GitHub, or you can write your own custom actions to do anything you need. The other important concepts, there's this idea of runners. Runners are basically nodes where your machine is. It's like a virtual machine where things are executing. You also configure virtual environments, and then you can configure secrets. So runners, there's really two flavors of them. GitHub hosted is like the default. When you set up a workflow, basically everything's going to execute on GitHub's server infrastructure. And that's great, and that works really well. But what if you have some specialized needs? Like, what if you wanted to run it on your own corporate hardware? Or your company already has a private data center, and you want to use that? Or maybe you have like some top secret code, and you don't want anyone to ever see your code, so you just want to keep it on your own servers. And the self-hosted runners allow you to do that. So the idea of self-hosted runners is actually, it was just announced, I think, like 3 weeks ago. So I haven't had time to play around with it. But the documentation is pretty interesting. And I'll contrast the difference between hosted runners and these unhosted runners. But it turns out that because GitHub is owned by Microsoft, they're using the Azure cloud to execute your builds and your workflows. So everything is running on Azure, and they've documented that. The only thing that's really doesn't run on Azure is if you are using a GitHub workflow and you pick Mac OS as your OS environment. Apparently Azure doesn't like have native Mac OS support. I guess they don't have like Mac Minis sitting in a data center. So there's actually a third party called Mac Stadium. It's a company in Atlanta, and they provide like hosted Mac Minis or something like that. So if you are building like an iOS app, like we were doing this at Saks Fifth Avenue, we had an iOS app. We needed a build solution that allowed us to run the iOS SDK and then sign our releases and promote from there. So it turns out that like being able to build on Mac OS is pretty important to anyone doing iOS. Self-hosted runners, basically you choose where you want the runners to execute. But there's some caveats. And this is a pretty serious like security warning that GitHub's documented. You don't want to use self-hosted runners with public GitHub repos. And the reason for that is explained here. If you have a public repo, someone can fork your repo, and then they can open a pull request against your source repo. But what they put in that pull request could be like, download a bunch of things from the internet, run some crazy scripts, do a bunch of things. And that's all executing on your self-hosted runner machine. And if your machine never cleans up after a build, or never, or isn't secure in some other mechanism, then you've basically just executed third-party code in an environment that you're responsible for. So something to consider. The virtual environments, these are like the 3 supported operating systems. Obviously, Microsoft Windows is there because Microsoft owns GitHub. Linux and Mac OS. I've only used the Linux environment. I haven't tried anything else. So the Linux stuff seemed to work okay for me. But in my work, I'm mostly just compiling Java projects or Scala projects or Kotlin projects. And for me, I'm just running the JDK in Ubuntu, and to me, it's all works. And they only would give you 2 choices for Ubuntu. And for the kind of work I do, this actually works fine. You also have the option of configuring, there is some other Docker support. So if you wanted to set up a Docker image and then set up a Docker file and have a multi-stage build where things execute inside your Docker or multi-stage build, you can do that as well. Secrets are an important thing, though, as well, particularly if you were, say you built a workflow and you wanted to deploy to AWS. There may be some credentials involved here, most likely. Or maybe you're just connecting to some other third-party API out there. And so they give you the option of setting up secrets inside your project's repo. And the way you access it in your workflow is through this, basically there's an object called the secrets object. And from there, you just reference the name of the secret that you're trying to retrieve. Setting up a secret is actually pretty easy. You do it through the GitHub UI. You just go to your project, click on Settings, and then on the left-hand side, you'll see an option for secrets. And then from there, you just add a new secret, and you can give it any name you want, paste in a value. It works pretty well. For better or worse, it works. And so some of you might know that a week ago was the GitHub Universe conference in San Francisco. This is like the annual developer showcase for GitHub, where they make all their big product announcements. So it was last Wednesday, they gave a keynote in San Francisco, and in the opening keynote, GitHub Actions was one of the first things they talked about. And what they announced was that GitHub Actions was transitioning from a beta release to a general availability release. So as of last week, it's a fully supported product. The APIs are stable. If you start using it today, it should work tomorrow. And then as part of the conference, they also announced some of their partners who have built third-party actions on the platform. So HashiCorp, with their Terraform product, they provide custom actions. Now they're officially supported by HashiCorp. And AWS also participated in the keynote. They now have some official actions built by AWS engineers. And Twilio has an SMS action as well. But I actually want to show you how I've used actions and workflows. Let's see if I can make this work. Okay, so there's a project out on GitHub. It's open source. It's called Guardrail. And this is a project that some Twilio engineers built. Guardrail is basically think of it as a library that will read an open API YAML file, and it will do code generation. And the code generator will output either Scala or Java. And so this project has seen a lot of activity. There's a lot of builds that happen. And I was super interested in enabling GitHub Action workflows in the Guardrail project. So about a month ago, I opened this pull request because I wanted to see if it'd be possible to make this work. And it actually wasn't that hard. We already had an existing Travis YAML file in the project. So I just strategically went through there and surgically copied and pasted things that I knew I wanted to execute over in GitHub's workflow. So let me see if I can make that bigger. But the basic idea is that you set up this YAML file, and at the very top of your YAML file, you set up the name. And then you have this entry on line 3 called on. And that means that you are declaring which events you are interested in subscribing to. So for this workflow, I was interested in, I wanted this workflow to be triggered by the pull requests that are opened or by any push events that happen on master. And those are really the only two things I wanted for this workflow. And then you configure basically the build environment that you want your workflow to execute in. So I picked Ubuntu latest. And then I also set up what's called a matrix, which allows me to do basically a cross build of 2 versions of Java and 1 version of Scala. I wanted to make sure that this Guardrail project was compatible with the Java 1.8 release as well as the Java 11 release. And so matrices allow you to do that. And then in the rest of the workflow, I was just setting up all the steps I wanted to do. And most workflows will look exactly like this. You will invoke an action called the checkout action. This action is provided by GitHub. They wrote it. It works. I've had no issues with it. And then after you do a checkout action, then you want to set up any build tools that you have. So for me, this is a Scala project. I need the Java runtime available. So you call this action called setup Java. And when I first set this up, I was wondering, I was asking myself, I wonder what version of the JDK they're running. Are they running the Oracle JDK? Are they running Open JDK? Are they running something else? And so I added this other step into the workflow called print Java version. And it turns out that they are running a JDK from a company called Azul Systems, which is down in the Bay Area. And they're a respected vendor of the Java runtime environments. So they basically repackage Open JDK with some other packaging enhancements and runtime enhancements. So this build will execute on the Azul JDK, and then the last step here, I'm just invoking the Scala build tool. And I have it run, I'm executing a full regression sweat test suite. And that's basically all that we did here. But I will tell you that we didn't delete the Travis stuff. We actually left the Travis file intact. And the reason for this was because GitHub Actions was in beta, and we weren't really sure when we were ready to switch. So what we did was we left Travis enabled, and then we turned on GitHub workflows. And so every time someone opened a pull request, we would do 2 builds, a build in Travis and a build in the GitHub Actions. So I'll show you what that looks like. Let's see. I'll go to a pull request, and let's see if one of these is I might have to go to a closed one. Okay, so when you're looking at a pull request, you should see this sub-tab called checks. And if I click here on the checks tab, this tells me that Travis executed the Travis workflow, and then GitHub Actions also executed its workflow. So I was really curious to find out whether the Travis build would finish faster than the GitHub build. And it might not be visible on the screen, but the Travis build here finished in 15 minutes. And that build is actually compiling two different flavors of the app. And then I configured the GitHub workflow to build the two flavors as well. But in the GitHub environment, GitHub actually splits them out as two separate jobs, and they run in parallel. So that alone just allows the build to finish faster. But let's see what the build step was. So this build finished in 12 minutes, which is really not that impressive. Let's see what the other build was. 9 minutes. So I was talking with my coworkers about how can we speed these builds up, because 9 minutes is not that great. We're hoping for something like 5 minutes or less. And it turns out that we are missing a key thing in our workflow. We are not caching any of the artifacts, the dependencies. So when you compile a Java project or you compile a Scala project, it's going to go out and fetch all the dependencies that it needs to do the build. And so I will show you that in the actual log here, you can see that when it's setting up the build, it's going out and just fetching hundreds and hundreds of jar files from a central repo. And unfortunately, that really slows down the build. And GitHub just added a capability that fixes this problem. There's now a new action called the cache action. And you can use the cache action within your YAML that designates that certain third-party libraries can be cached. And so the next time you run the build, it will restore that cache onto the node where the job is executing. And that way your build can get all the artifacts quickly. All right, so that is Guardrail. That was a fun little thing to work on. But if you have your own public projects, just go to the Actions tab in any of your personal projects on GitHub. You'll find the Actions tab, and that should be a good way to get started.
Just a quick question. Does Travis allow you to cache?
I think Travis has a mechanism to do it. Yeah.
Okay.
Yeah, you have to set it up though. It doesn't happen by default. All right. So there's also an SMS action that I mentioned. This is something Twilio built, and this was featured in the keynote last week. But the idea is that if you had a multi-step workflow, there might be a point in your workflow where you want to send out some sort of notification as a text message to somebody saying urgent, please look at this. And so you can embed this custom, this action into your workflow. All the code for it is on GitHub under what's called Twilio Labs. And then from there, you drill into actions-SMS. And the way that you build an action is actually pretty straightforward. You have to provide a file in your repo called action.yaml. And this is just a descriptor of the capabilities of your action. So you have to declare the name of your action, the version information, I think, can't remember. You also declare all the inputs that your action will accept, and then you declare all the outputs that your action will produce. And then you also have to declare this line called runs, and you specify which runtime environment where your action executes, as well as an entry point for your code. So that is known as the main entry point. And so the way most people build actions is with JavaScript. So you can use JavaScript or TypeScript, although I think you have to compile the TypeScript down to JavaScript. And that's like, if you go out and look at any action that's out there, pretty much all of them are using TypeScript or JavaScript as their implementation. And then that's not the only option. I'll show you how Terraform did it. So Terraform didn't want to use JavaScript as their implementation language. And they came up with something different. So if you drill into the HashiCorp repo and find GitHub Actions project, you'll find that they have an action.yaml file. And you can see that their action is implemented through Docker invocation. So you set up a Docker file, and you could put anything in it. It doesn't have to be JavaScript. It could be just some native binaries that run on Linux or any other Docker-supported image. And that's what Terraform did. The reason they did it is because Terraform already has command line tools that are natively compiled and run on Linux. So they wanted to use their CLI tools to provide the implementation of their action. So that's how they did it. And AWS now officially supports a couple actions. They've set up 4 of them, and they have a special repo where you can find them. This was released last Thursday. It's called AWS-Actions, and I should warn you that if you just search GitHub AWS Actions on Google, you may find some things that were written by some non-AWS people. And I'm sure there's a lot of good third-party solutions out there. But if you want the officially blessed actions, then you have to go look at this AWS Actions repo. And so what these actions do, they've only released 4 so far, but they've got one for dealing with AWS credentials, and then they have one for dealing with the container registry. So if you need to log into the container registry, and then you might want to push a container image to ECR, that's supported. And then they also have a deployment task for ECS. So I haven't had a chance to play with this. It's only been out for about 7 days, and the only thing I've heard about these tasks were what I saw in the keynote last week. But if you dig into the repo on GitHub, it turns out that they implemented everything with JavaScript. So if you look at all the repos that they actually have 4 repos, and each one of those projects has an action.yaml, and all the action YAMLs contain basically this, a main statement that invokes some JavaScript. So I guess the recap is that the GitHub platform has all these events. Opening a pull request is the most common event that you'll encounter. Most people want to trigger a workflow based on a pull request. It's really easy to set up. And then inside of your workflow, you'll have multiple steps, and then those steps are known as actions. So you invoke either your own actions or you invoke actions that are provided by third parties. And you will spend a lot of time editing YAML. This is kind of unavoidable. I say it's unavoidable. I mean, realistically, you could probably find a working example that someone else wrote and probably just copy it and then tweak a few lines. That's like 90% of what I do with YAML is just find a working example. I will show you how you can skip over the YAML pane just a little bit. So GitHub, let's see if I can find this. GitHub has this thing they call starter workflows. And these are pre-written YAML templates that they give you for free. And so if you go out into this project, starter workflows, and you scroll through this list, you'll find that they've pretty much built a workflow, like a really simple hello world style workflow for pretty much every language or developer tool you could think of. So if you were using, let me see here. So if you're using Gradle to build a Java project, they've already got the Gradle system already kind of like pre-configured here. And then let me back up. They also have Rust, Ruby, all the usual suspects. Scala is supported as well. They just do a simple, this is like the simplest possible thing you could do with Scala, which is set up one version of the JDK and then just compile your Scala code against one version of Scala. And that's basically what they're doing here. So if you already have a project on GitHub, it's actually really easy to just enable it with one of those starter workflows. And I'll show you, this is a library that I worked on a few years ago. Anyone who worked at Guilt might know these libraries. It was called GFC, which meant Guilt Foundation Classes. And so I think it was inspired by the Microsoft MFC, which was like 2 decades earlier. But if you have a project out on GitHub, just click on the Actions tab, and it will try to auto-detect your project type. It will look at what source files are in your repo. And it's made an intelligent guess. It guessed correctly that the GFC cache is written in Scala. And now it's asking me, do I want to set up a default workflow? So I'll just click here. And here it's really just copying the starter template out of that other repo, and it's copying it here into this editor. And it's asking me, do I want to edit this or customize it in any way? And I'm just not going to touch it. But the basic idea is you could tweak it here if you really wanted to. But if you like the way it is, just hit the green button at the bottom. And then they give you the option, are you ready to commit this? And sure enough, I'll just commit it to my repo. So now it created this subdirectory for me. It created .github, and then it created workflows underneath that. And there's the YAML file. So if I click over here on Actions, you can see it's already triggered the first build. And that build will probably take 10 minutes while it fetches all its dependencies. But pretty easy to set up, pretty good user experience. You don't need a lot of YAML knowledge to just click those buttons. So you can avoid editing YAML, but eventually you will need to go into that file and like customize it. And sure enough, like once you've set up a workflow, it just starts triggering and just starts executing. So things run pretty much as expected. Yeah. Any questions?
Hi, thanks for all this. Is there an example where this action can build a container instead of those Java script and all that?
Building a container instead. Yeah, I think I actually haven't written one to do that, but you can set up. So you can set up. Let me go. Let's see if I can find the better example here. So if I go to starter workflows, where they had all the templates, they actually did have some Docker related templates. I don't know, that push is the one I wanted. Let's look at Docker image. Yeah. So when you're setting up the steps of your workflow, a step can either invoke an action or it can invoke some other like command line tool. And the Docker CLI is pre-installed in Linux and Windows, and I presume they pre-installed it on the Mac. So yeah, if you have a Docker file, you just run Docker build. Yes.
I have a question. So we have to create a different file for each workflow on push, on pull request, on push, on master.
So you can set up. You have a choice of how you set up the workflows. You could have one workflow that reacts to multiple events, or you could set up multiple workflows where each workflow is triggered by a different event. In fact, that reminds me, I've got a better example of that. So I have an open source library that's related to emoji images. Don't ask me too many questions on the emoji things I'm doing, but basically I wanted to rebuild my emoji images on a schedule. So I wanted to have a cron job that basically does an image conversion of SVG files into PNGs. And I wanted to refresh this once a day. And so I set up a GitHub workflow that does that. And so I named the file daily.yaml, but you can name it anything. And for me, this is a cron event that I wanted. So I scheduled. I actually don't even remember cron syntax. I always have to Google it. Cron syntax I think is worse than YAML syntax, and so this is like the worst of both worlds, where I've embedded cron strings inside of YAML. But anyway, that's the schedule I wanted to run daily. And then I set up some steps. So my steps are like, I call apt-get to install some like open source library for dealing with SVG files. And then I have a local build.sh file. That's something I wrote, and I wanted to invoke that. And then I do a bunch of nonsense here at the end. It turns out I actually didn't finish debugging this script. That's why I didn't really demo it. But this actually does run once a day, but it sends me an email telling me that like I misconfigured like the last step. I'm actually trying, at the end here, I'm trying to do git add, git commit, git push. I actually didn't set up the GitHub token, which gives me permission to push back to my repo. So without having the right like tokens enabled, like this is not going to really do what I wanted it to do. There's a different approach I'm going to take for this, but that's one way that you can react to an event. There's also, let's see, here's like another project where this is an open source framework for Java. It's called Micronaut. Sort of like Spring Framework, the next generation. And so the open source team that's building Micronaut, they adopted these workflows, and they wanted to have two different workflows. They wanted to have one workflow that just reacts to pull requests, and then the other workflow just reacts to tags. So when someone tags the repo and pushes that tag, they actually want that to trigger a build and release where they actually upload the artifacts to a public repository. So here you can see they created this workflow called release.yaml, and this workflow will only execute if someone has created a tag that begins with the letter V, and then they push that. So that will trigger all of the steps in this workflow. And basically what they're doing is they're doing a Java build, then they upload some artifacts to the bin tray repo, and then they also upload some artifacts to like Maven Central somewhere here. But and because they're interacting with these public artifact repos, they also needed to provide the credentials. So like to authenticate with the bin tray repo, they had to set up secrets as well. So it's pretty flexible. You can do a lot.
Thank you. I was wondering what are some issues you ran into which make you feel it might not be a great fit for larger teams? So one thing when I looked into it that I didn't really like is that I think, for example, for these secrets, you can't really control who has access to the secrets, right? If you have write access to the repo, everyone can see all of the secrets, I think. But like I know you can solve it in different ways, but I was just wondering if you ran into specific things where you feel for production work and larger teams it might not be great. Yeah.
So in the beginning here, they've set up secrets as a per repo setting. I think you can set up users that have admin rights within that repo.
Yeah, that was what I was looking for, but I think I couldn't find.
And
they don't have that. I don't think they have it yet.
Yeah, I can't remember. I have admin rights on all my repos, so I haven't looked. The other thing that I heard discussed online was that people were asking if they could just configure secrets at an organization level, and so that like if you were a corporation and you had like 10 teams with 10 repos, maybe you just want some global secrets. I'm not recommending this, but there were people who were asking, like, could I have centrally administered secrets? And then they wanted to just have the corporate administrators just have access to set up secrets and not allow developers working in individual repos to read or write secrets. I'm not sure that's really implemented yet. I know that people were like debating that idea online. And the other thing that's sort of missing from an organization level is that some organizations would like to have like a single dashboard where I can see all the workflows that are executing in my organization. And I might want to see like what was built most recently in my organization. Well, right now I don't have a centralized UI that just gives me that. And also, as far as administrative control, people might want to block or authorize certain actions because there are lots of third-party actions out there, and you may want to set up a security policy that says, you know what, I'm only going to trust actions that are implemented by GitHub. Like GitHub provides a suite of 40 actions. I'm just going to authorize those as a security policy, and I'm not going to allow any other actions in any of my organization's repos. And there's talk of that coming in the future, but it's definitely not available now. Yeah, so I mean, I'd say like, this is like the 1.0 version of GitHub Actions. It's just sort of the foundation for the future.
Thanks.
All right, so I have a very stupid yet hilarious question. So I don't know if anyone here is familiar with the notion of a fork bomb. Basically, it's like a program. It's just while true fork, and it just replicates itself infinitely. So could one potentially create a GitHub action that responds to a push by creating 2 new commits and then pushing both of them? and what would happen to your Azure bill if that happened?
I actually don't know what would happen. I haven't tried that.
You'll run out of hours.
Makes sense. Well, the serious question is there a timeout to protect you from having something go out of control?
I know that there are CPU and execution limits set up. I don't, off the top of my head, don't know what they are.
Thanks.
Okay, this will be a follow-up question. Looks like this action is really positioned for the CI space. Now, currently, that Jenkins also in the CI space. How does this product coexist with Jenkins? What's the future plan for integrating together, or is this a prospective replacement?
I mean, there's classic Jenkins, and then there's also a new version called Jenkins X.
Jenkins X goes into the CD space, right? So
yeah. So I think this GitHub Actions is just kind of like everything's pre-integrated, and you can also like manage all your users and user access all in one place. So there, it does have that, single point of integration that maybe some other products don't have the same tight level of control. But at least for like open source projects, I mean, this is kind of a no-brainer. I think this is quickly becoming the default for new open source projects. Every time I'm out on GitHub and I click around and look and see what people are using, more often I'm seeing new projects that are using GitHub Actions and workflows. I know that in the past, like in past jobs, I've worked for companies like Guilt.com used to have a Jenkins build environment. And we were self-hosting it or self-managing Jenkins nodes, and every so often we'd have to like kill Jenkins nodes and do crazy things. But, I don't think there's a lot of companies that want to set up Jenkins infrastructure. It was certainly like a burden to it's undifferentiated work. It's heavy lifting that most enterprises don't see any value in implementing on their own, having their own people do it. It's better to have a hosted solution. And at least for the work that I'm doing on open source, I mean, Actions is pretty compelling. It's worked for, I've converted like 10 projects that I've moved into the GitHub workflow, and it's so far working pretty well for me.
So let's see, if you're an enterprise that's already heavily invest in Jenkins, right? So that pretty much has taken care of the CI space for all the past 10, 15 years. How do you motivate the developer to move into the Actions? Right, especially now if they have a Jenkins X looming in the space, where Jenkins X will cover the CD space, right? So how does that work?
So if an enterprise already has a Jenkins investment, they should probably keep using Jenkins. I mean, if the switching costs are high, then it may not be worth switching. Anytime you switch platforms that you're deeply entrenched in your company, I mean, it may not even be worth switching over.
Well, no, I'm just comparing this recently that we're testing the Jenkins setup in Kubernetes. It's just one click in like 3 seconds. Jenkins pops right up, right? So that was kind of attraction for people to just continue to migrate over. But this one here, just trying to see what kind of things would convince people to adapt to this. This definitely has some event-driven characteristic, where we can have more control of it.
Yeah, this solution gives you the ability to precisely receive GitHub events. So I had a slide where I showed like eight GitHub events. I mean, there's actually like way more than that. I mean, there's 50 or 100 GitHub events in the platform. So it gives you a lot of control to just precisely react to events in the GitHub lifecycle. So if you need that level of precision, this could be useful.
One thing I wanted to add is that because it's so easy to set up something very small to add, like a very small action to add right besides your Jenkins setup. It's pretty easy to justify trying out part of it, I guess. And I did see that Jenkins also built a Jenkins runner, which allows you to run your Jenkins file on a GitLab. Like they published it themselves, where you can just launch your previous Jenkins file on a runner from a GitHub Actions. Whether you'd want that, I don't know, but.
Well, actually, yeah, the challenge here is that Jenkins has like tons of plugins, right? So all the plugin right now is embedded in this CI process. So that's the challenge here is that there's still version 1 data, but it's a very promising technology. Okay, thank you.
Yeah, you know what you said about like Jenkins having custom plugins. I mean, we did have, when I was at Guild, our build server did have like some third-party open source plugins that we added in to customize the Jenkins, and so like we were able to tailor it to do exactly what we needed. But if I were starting a new startup tomorrow, I don't think I'd set up Jenkins infrastructure. All right, cool. Thanks for coming. I will hang out here for a little bit longer. Thanks.
Hey everybody, thanks for coming. Like I said, this is the last one for 2019. We'll have our 2020 schedule posted in the next month or so. But if you have a topic you'd love to talk about, come get in touch with me either through Meetup or directly, and we'll get you scheduled. Thanks. Have a great night.